Alright, this is lesson 2.8 of our Pre-Calc 11 class. Unit 2 is called Polynomials. Lesson 8 is called Characteristics of Quadratics. What we're going to learn in this lesson is more about what is a quadratic and what are some words we use to describe quadratics. Okay, a quadratic comes from with the prefix quad. Quad means square or rectangle. As in anything with an x squared as the highest exponent can be written as a square or rectangle geometrically. That's interesting. Also, polynomial, it's also a quadratic is known as a polynomial of degree 2. Degree 2 meaning the biggest exponent on x is 2. We can graph a quadratic. If we do so, it makes a shape called a parabola. Looks like a U. 6 examples. Which ones are quadratics? A is a quadratic. We have x squared term and an x term. B is not a quadratic because it has an x to the power of 3. C is a quadratic term. We have x squared and a constant term. D is not a quadratic, as in there's no x squared term. This is actually a linear. E is a quadratic. I don't see an x squared, but if I multiply these together, I get x squared minus 2x minus 3, which has an x squared. The second one has 2x squareds, but I can add those together in quick-like terms to get just 2x squared. So this one would be a quadratic. Okay, some words we're going to use to describe quadratics. Vertex is a word. Roots is a word. Y-intercept is a word. Axis of symmetry is a word. Maximum is a word. And minimum is a word. These are all words we use to describe what the graph of a quadratic looks like. So, a couple ideas just to get an idea for it. The vertex is this point right here, point B. The vertex for this one is G. And never mind the scribbles on that problem. The vertex on this one is J. By vertex we mean either the lowest point on the parabola or the highest point on a parabola, or as I like to call them, hills and valleys. Okay, roots. A and D are the roots for this. E and H are the roots for this one. Where's the x-axis? Right here. So I and K are the roots for that one. Roots are where the parabola intersects the x-axis. Roots are also called x-intercepts. How many roots? One there, 2 roots. Again, this is the x-axis and the y-axis. Roots, there are 2. 1, 2. How many roots here? There's only one root. What's another root for this root? It's also the lowest point of the parabola, so this root is also the vertex. So, if the vertex is the root, then there is only one root. This one, 2 roots. 1, 2. This one, no roots. No roots for you, Springfield fans. Seinfeld fans. Embarrassing. The x-axis is up here. The parabola is down here. The parabola doesn't touch the x-axis, so there's no roots. Maximum or minimum? Well, the vertex B is the lowest point possible, which makes this have a minimum. This one's a hill, so the vertex is at the top, which means we have a maximum value. Minimum value, minimum value, maximum value, minimum value, maximum value, maximum value again. Okay, line of symmetry, or axis of symmetry. The blue line is the axis of symmetry. It is the line that cuts the parabola in half, almost like a mirror. The left half and the right half are mirror reflections of each other. The axis of symmetry also cuts right through the vertex. The axis of symmetry is also equidistant from each of the roots, as in the distance from the axis of symmetry to each root is the same width. There's the axis of symmetry here. I'm a little off with my red line. My apologies. Here's the axis of symmetry for this one, the blue line, red line, green line. Okay. So we know that a quadratic is a polynomial of degree 2, or has an x squared, and we have some words to describe quadratics. And that's it for this lesson.